Hello, everyone. My name is Ryan Booz. I am a developer advocate here at Timescale. I help lead the developer advocacy team. To have one of my members join me today. They are one of my team members. Oh, and it looks like Attila's finally here. All right. I know he's been having some issues, so let's get him on. Hey,
Hello, can you hear me?
how you doing? I can hear you. It's good to see you.
Awesome.
So I
Yeah.
like this setup because when I did this with 𝗔𝗯𝗃, I have a multi-screen. If I put you over here and I look, it looks like I'm looking at you and we're having a face-to-face conversation
Exactly.
almost from around the world. It's great. Well, Attila, how are you doing today?
Good. To be honest, when you said that you will talk about continuous aggregates and you will use the NFT data set, I was like, it doesn't get better than that. So I'm
There
really
you go.
excited.
So for those of you who don't know, I'll show you here in just a minute. Attila worked really hard. We had a good month of October at Timescale. We had a whole month of launches, lots of content, new features, actually some kind of new products to an extent. In fact, I'm wearing my official Timescale Community Day shirt. I just got it yesterday. So we had a good Timescale shirt. You look fitting today.
Yeah.
So we were, I know, right? We were able to have a number of users join us and just other engineers in the company and talk through some good stuff. So the culmination of the whole month, we had been talking about this for like 6 weeks, preparing for it, and just excited. So one of the reasons or one of the use cases that so many people use Timescale for is crypto, right? We get a lot of these questions.
Yeah, a lot of stocks, a lot of crypto, and I haven't seen a lot of NFT stuff, but I'm sure if this trend will keep going and NFTs get more popular, we're gonna see some queries about like, hey, how can I do this with the NFT data? But yeah, definitely crypto is one of the most used data types and schema. Yep.
Yeah, for sure. Yeah, blockchain. I mean, I think over and over we just see this idea of people wanting to know how to explore data that honestly isn't always really easy to explore, right? Like we have even something like NFTs. I think that's what you found in doing this is there's a lot of data you can get. Quite honestly, the OpenSea API, which we'll see briefly, or at least the end result of your work, there was so much that you could learn just about individual NFTs and collections and assets. And how do you think about a schema and use features like continuous aggregates to make that exploration easier? Was a
Yeah.
challenge, and I know when you guys really worked hard towards.
Yeah, I mean, the interesting thing is that as you said, a lot of different diverse set of data fields in the just in general, the whole blockchain has a lot of interesting data fields, but continuous aggregates, I think, is probably the most useful features when it comes to uh, just trying to make sense of the data in a fast way.
That's
So
great.
I think
Yeah,
it's very cool to combine those two.
that's the goal, right? Let's hope that see what's happening. So let me say a couple things as we get started. Number one, we are following chat both on YouTube and Twitch. So if you want to make some comments, we will see those comments as we're going. For those of you who are seeing this after the fact, feel free to make comments in YouTube. We will record this and make sure it gets on YouTube after a little bit of editing. And this is just part of the discussion. So what we're doing today, I'll go ahead and share my screen, is we're restarting a number of series, and one of them is Timescale Tuesday. And so it's something that I had done some when I was one of the only two advocates here. Back in the winter, January, I think I started doing these as often as I could on Tuesdays, just talking about features, questions, new features, problems that we saw often in our community channels, even from support and elsewhere. And so we just wanted to give maybe some new perspective, trying to work out some of those problems. And so this will not be the last time we talk about continuous aggregates. Quite honestly, Attila, you did a video a few months ago on this. I've probably done 4 or 5 videos over the last 8 or 9 months on continuous aggregates. And that's for 2 reasons. One is there's just a lot to think about in continuous aggregates. There's a lot of potential and opportunity. There is definitely some misunderstanding, and part of it is we'll talk about coming from most other solutions like a materialized view that doesn't have this ability to be continuously updated and retain history. So that's one of the strongest features, not the strong. I mean, there's a number of good features, but it's really unique in the world of the data world that we live in with Postgres and elsewhere. And honestly, then there's just some new features. So we're going to talk briefly a little bit today about reaggregation. That's probably one of the most common questions we get is, well, I have this aggregate that is 10-minute data. Why can't I write a query over that aggregate that's already pre-aggregated for 1 hour, right? That would save me so much more computation. Why do I have to have multiple continuous aggregates? Well, we're making strides in that direction. So we want to talk about what that looks like and some of the features we're doing. So all about refreshing continuous aggregates. The focus on this is mostly about refreshing. And that's why I titled it that, because that is where I see the most confusion. I think you and I have seen that, particularly in the stock and crypto area.
Yeah, when usually when people have a system where they fetch new stock prices or crypto prices constantly, they want to see the sort of most recent data points, and they try to set up these refresh policies, so they get what they expect. But if you don't understand like continuous aggregates properly, you might not get what you expect. So I think it's a
Exactly.
really it's one of those things that once you understand how they work, they become really, really useful, and you get what you actually expect.
Yeah, that's great. That's exactly it. I mean, I think it's just the power of knowing what it is you need to expect for the data you're trying to produce, right? So let's talk about it. And I will just say this, I say this often. I came to Timescale as really a former user. I was working on a large IoT company, so industrial IoT. So it wasn't specifically crypto, but very similar use case where we had, quite honestly, just hordes of data coming in every minute, from hundreds of thousands of devices, and needing to think about something like a continuous aggregate. We had a different system built on Cassandra that we had to build all this stuff manually. And the potential of saying, I can set up a couple of these aggregates that will maintain the data. And as we'll talk about early on, real-time aggregates give me access to that new stuff when I need it is just really exciting. But even then we had, maybe a little misunderstanding of exactly how it worked. And some of that misunderstanding is helping to drive how we develop this in the future. So here's what we're going to cover over the next, maybe 45 minutes, something like that. If it goes shorter, great. If it goes to an hour, that's okay too. And again, if you have any questions, please don't hesitate to put them in Twitch or YouTube, and we should go ahead and see them here. So we're going to again cover, I feel like I can't cover this enough. What are continuous aggregates? There are numerous videos, which I will do my best to link to in the description once this video is done and posted on YouTube. Both Attila and I, at least, and some others have done numerous videos on this. And so, this is kind of a rehash, but I just feel like anytime we talk about this, we need to go through it. We're going to talk about what that refreshing data really looks like. I just want to pose I think I have 4 or 5 kind of general questions that we hear, common questions we hear often. Someone comes into the Timescale fold, they're excited about their data, they set up a continuous aggregate, and these are probably the top 4 or 5 that I get. Attila, I didn't show you ahead of time, so be interested to see what you think. And then we'll go ahead and demo through this data. I'll show you the data we're using and try and refresh some data, import some new data, things like that. I will give this caveat, and I say this to Attila and the other advocates all the time. If I've learned one thing in the last year of being here, it is that demonstrating time series data is really difficult because it's always moving. And unless you are generating it, it's always moving and it's always UTC based, right? So I'm thinking about my local time, but it's being stored in UTC. And if it's not queried correctly, I don't always get what I expect. And so it's challenging. So I hope these demos work. I've tried to run through them. We have now flipped over the top of the hour where I'm at. So it is 12:15 in the afternoon for me. I'm in the East Coast US. So the data that I'll be querying, or the data that I'm getting from this API, is obviously in UTC. And so it is 5 hours ahead of me. So I think that I flipped over the hour. I should be able to demonstrate everything. There is a chance that something won't work as I expect, simply because of that whole workings. So let's see what happens.
Yeah, and what's interesting, like it's, generally you have this question, like when doing demos, like you need to have literally the demo gods on your side to make everything work. But here you have another level, which is just this is just the nature how time series data is, which makes it
Yeah,
more challenging, I guess. But yeah.
for sure. And it's hard because I think when we've shown this previously, it's easy to use, like, let's just create data from January 1st to January 15th. It's like, but that's just this historical thing. My goal in this demo, I hope, is to show you actual data that's occurring right now. We're querying it from an API. And if I were reusing this like we were showing, I hope this all works. So you can see that it gives it a little bit more tangible feel of this is what you are actually doing. Not many people are just randomly creating data from a couple months ago because it allows me to show something easily. But all right, so feel free to hop in anytime you want. If I'm getting something wrong here, some of these slides, like I said, are reused, and again, just to give us a bearing and a basis. So continuous aggregates. We know what time bucket is. If you've used Timescale at all, it's our function that allows us to aggregate data over arbitrary moments of time, right? So in this case, I'm saying 1 hour. When I run this query, it's going to divide up the data into consistent hourly buckets starting from now. So it'll go on the hours and so forth. I can just say anything I want in here. I can say time bucket, 1 day, time bucket 6 minutes, time, whatever. It's an arbitrary interval of time, and we'll create those buckets and go forward. And you can do other things with it. You can specify like the start time. So if you actually wanted it to be offset by half hours, or there are all kinds of things you can do with it. But this says, I want to take the raw data. So we're going to kind of pretend that the gray dots down here are the raw data that's in my hyper table. And when I say time bucket, Timescale is creating 1 hour buckets of time to aggregate data into. And in this case, in the example query, we're taking a max and an average of some value inside of each of those hour buckets and getting that data. And so what this ends up meaning for a lot of people, particularly if you have used Postgres before, I also came from a SQL Server background. And so in that space, it would be an indexed view. And the idea is in Postgres, there's a concept of a materialized view. And that means that when I run the data, I create this query, and it's not just a view. So for those of you who don't know, when you create a view in really any SQL database, that is not materialized to disk. Every time you select from that view, it actually first goes and runs the query and then gives you the data back. So you're saving, it's nice because you can create a unique view on top of your data, but the data has to be queried every time. And so Postgres has this idea of a materialized view. So it will, at the moment you create the materialized view, it will actually store the raw values to disk so that when you query it, it's much faster because it actually already has the values. So it's really similar to that. That's kind of the TL, too long didn't read. And we use time buckets. So you must use the time bucket function to aggregate queries into whatever those buckets might be. We hope that continuous aggregates help to speed up your long-range queries, right? We're helping to pre-aggregate data. And then the cool thing here, and this is the unique part of it compared to a materialized view in Postgres, even up to Postgres 14, which is just released a few weeks ago, there is no way or concept at this point of saying, hey, I created this materialized view. I have a year of data. I created this view maybe with 1 hour buckets, what have you. If I add new data or I modify old data in Postgres, I can't just say, hey, can you just go update that little portion over there? That just doesn't work at this point. So that's what continuous aggregates, that's what we have allowed to happen in our continuous aggregates. So we can pre-aggregate the data, and if something changes or you add new data, we don't have to throw the whole thing away and recreate it, which is what happens with the materialized view. We can, Timescale keeps track of those changes and says, oh, okay, I'm just going to go update the most recent period. That's the new data. And it turns out you modified something, yesterday. I'll update that portion in time too. So we can do that, and you can do it on a schedule, which is great. Again, with materialized views, you would have to do all of that manually, even to get it to update when new data comes in. So again, we take this materialized view, and the difference here from our previous query, the time bucket query is just getting you the raw data. Here we are saying create this materialized table that's going to live on through time, but it should be the same as the query, if I were to run it at that moment in time. And so hopefully it saves you some of that upfront computation. The other, some of the differences, I'm going to mostly put these on the screen. If you want to pause the video, I'll really quickly talk through this. And if you have any questions, okay. This is the problem with the animation. I should be looking at my animated slides over here to see when I get to the end, because I forget. Continue, I kind of already said this, continuous aggregates. The reason we're able to do that little update or portions of the view update is because we actually store the data in two ways, which I'll show you later. One is we store partials. So we don't actually store the value that is calculated. We store the components, and I'm going to show you a great article you should read. What we are actually storing is the components that when you use that function, so let's say average. Average for a bucket is all the values added up divided by the total number of values. So what we store is the total value and the total number of values. So when you then ask for it later, we can materialize it and give it to you. And the reason we do that, and the reason we chose to do it that way, was because we can then update those individual slices of time. That's cool. And at some point, at least in the original design, we wanted to take into account the ability to take multiple partials and create a different value. So instead of a 1 hour bucket, maybe we plan to provide the ability to say, oh, well, if I want the average over a day, I just need to now sum up all of the individual hour partials, the total count, and I should get the same value. So it's not an average of averages. A couple other things in here, only refreshes the part, and we already talked about that. Then probably the other cool thing is that it's partitioned. So continuous aggregates actually have the same underlying architecture kind of on disk that hypertables do. So when you create a continuous aggregate, it creates partitions. They're bigger partitions because the assumption, and that's something you can actually modify, but the assumption is that you're taking a lot of raw data and you're aggregating it into smaller buckets. So we start at a tenfold. So let's say your hypertable has a 7-day chunk time. When you create the continuous aggregate, by default, it would get a 70-day chunk time. And again, the assumption is you're reducing the number of rows pretty significantly. A couple other things you can look through there. The only other thing that I would say is, these are some of the things we are currently working on, and some of the things I'll show you here. So number one, as we said, it can be refreshed automatically, which is cool. But really this last point, you'll see in the examples that we give in documentation, even in this NFT sample, that it is a one table aggregate. So that is one difference to materialized views. Materialized views, they cannot be refreshed. It's a point in time view of your data, but it can be a complex query because it's actually executing the query, storing the actual calculated values, and that's your data. Because we are tracking all of these modifications, if we were to allow you to join in multiple hypertables or multiple relational tables, that would mean we now have to somehow watch for modifications anywhere. So a great example is this. I think you and I talked about this, Attila, even with NFT data. Let's say you get the NFT data for a collection or I would say a collection, and you're tracking I guess, an asset, and you're tracking the sale of an asset from person to person. And if someone changes their username in their, on the blockchain or in the OpenSea, now you have to refresh all of, if we allowed you to join all that in and stored those values, now we kind of have to go block by block, person by person, chunk by chunk, and refresh the stored value for that individual. It doesn't mean it's not possible. It just means it adds a complication that we wanted to focus on time series data, right? How to make that data smaller, faster. Once you have it, you can still join all your relational tables. So maybe you store the ID, which in theory shouldn't change. And then if you need the user's name in that case, you join to the username. I think you did some of that in the NFT
Yeah.
queries, if I remember, right?
Yeah, and with the NFT data set, it actually was. So I had a materialize. I had a continuous aggregate, obviously without joins, but it wasn't really a problem because basically what I use the continuous aggregate for is to just give me aggregated data quickly, and then I can do the joins, using the aggregated data. And this
Right.
way it was fast, and I was still able to do my joins.
That's great. Cool. All right. So how can continuous aggregates help? Well, hopefully, again, the whole goal here is to save resources. If you don't have to run a view, right? So remember, every time you query a view, even though you could make a more complex view, every time you query that view, you're actually running the raw query under the covers in Postgres. So you're not saving any resources. You're simply providing maybe a more effective interface to your data, right? So it's easier for others to query. They don't have to know all the nuances of the columns. You're creating a view that's easier for them to get their data. That's a valuable thing to be able to do, but it doesn't necessarily save query time, resources, response time, that kind of thing. And unlike an actual materialized view in Postgres, we're saving resources by not having to recreate that view every time. So what most people have to do right now with if a materialized view would help, is they have to kind of schedule when they want it to be updated. Hey, I get new data every hour. It takes this materialized view 10 minutes to create because it's querying a year of data or something. And you have to kind of figure that out on a trigger basis. When X happens, trigger this thing over here. We're going to rerun the materialized view and get the data. So that's the real goal, hopefully, saving resources. And the other thing to recognize is, in theory, as I said earlier, you're actually compressing that data, because the example is this: if I have minute readings for 1,000 devices, in theory, that's 60,000 rows an hour of data, just in raw numbers, something like that, right? And if I then make that a 1 hour aggregate, I'm literally storing 60 times less data, right? I go from 60,000 rows for those 1,000 devices to 1,000 rows, because I have now 1 row per device per hour, rather than 60 rows per device per hour. So that's the idea. That's the hope. And everyone hopefully wins. With this, the difference here is, and we've that thing did not start drawing like it was supposed to. Sorry about that. The idea here is that, as data comes in, we then give you that ability to refresh it. And so that's what we want to show you here in a little bit. Right. So the green dots are, I've created this hourly summary. I already have blocks of time, but I have a couple blocks. A couple things have happened here. I have 2 blocks of time that maybe have not been materialized yet. And so I get some new data down here in that period of time. And I have some data maybe in the history, maybe the last day, something got updated. I got some new data late, something like that. And so with a refresh policy, we want to basically try and determine, and this is really one of those first keys. In general, I do have to know a little bit about my data and how I expect it to be working. So with the NFT data, we are querying the OpenSea API. I don't know do you happen to know? I never asked you. What is their policy? Like, how quickly is the data available in the API? If you don't know, that's fine. I just never
So
thought to ask.
no, I there is nothing. At least I didn't find anything related to that in their documentation. But if you actually try out, like they have new data, at least the API gives you new data points like literally every second.
Okay.
So
yeah, and that's what a lot of our use case, that we hear about do, right? People are looking for lots of data that's coming in pretty frequently. So the two questions that generally, or two answers we generally give people, and I'll explain this in a minute, is you have to decide, number one, how much resource you want to provide to this. Let's just say if this is a 1 hour summary, this is about 12 hours of time, let's say, right? So half a day. And maybe for my situation, there really are cases where I have data like these points back here that are coming in 4, 5, 6 hours late. Maybe it's an IoT device that goes offline sometimes and comes back online. But I never expect data, under most circumstances, I don't expect new data or updated data points to happen more than 12 hours ago. Well, then there's really no reason to ask Timescale to keep track of and potentially go update data for all of history for this continuous aggregate. That's one of the goals of a refresh policy. Is to say, choose a period of time that's most likely to have changed data. Obviously, most recent data, probably you're getting new data. Maybe the last 3 or 4 hours. It gives you the ability to update a problem or receive some late data, things like that. And then we're going to talk about manual refreshes. So this is probably the first time that I see most people. So the update policy might look like this. If I had a 1 hour bucket, I might say, for me, I want to make sure the last 12 hours are always up to date. There's a chance in the last 4, 5, 6, 10 hours, I might get some late data. So every time that the refresh policy runs, just go look over the last 12 hours and make sure we're up to date. Update any, rerun any aggregates that need to be run within that period. This does not mean that all of the data for all of the 12 hours is going to be rerun. We watch the buckets and we try and update only the buckets of time that change. And we try and do all this as intelligently as we can to save time and resources. So this is probably a reasonable policy. It's a 1 hour bucket, and we'll see that it doesn't, in a little bit, we'll talk about this. It doesn't really do me any good to run it more than every hour, and you'll see why in a little bit. But this would be a really good policy for something like that, maybe. If for you, maybe you get data 3 days late sometimes. Great. It's probably okay to say the start offset is 3 days ago. It might take longer to run, but saying, well, just always run it for all of time or always do it for the last month, you're probably burning a lot of potential cycle for not a lot of benefit. And we'll talk about some ways to do that. Any comments?
Question. I have a
Yeah.
question.
Yeah.
So how would you? So here you have 1 minute set for the end offset, and do you need to consider the rate that you have new incoming data, and then basically the size of these buckets that you have
That's a
in
great question.
continuous aggregates?
Yeah, it's a great question. I would say here's the only rule, and I'll start there and then I'll answer your question. One is, and you'll see why in a little bit, but the start offset needs to be at least 2 bucket widths, and you'll see why in a little bit. So for a 1 hour bucket, this needs to go back at least 2 hours, and we don't let you create a policy unless it's at least 2 hours. All right. And I'll show you why in a little bit. That was not always the case. We saw some issues with people trying to create policies that really didn't do you any good. And so we put that in place. The reason I chose an end offset of 1 minute is honestly, so what happens is the policy runs currently in Timescale, the policies run, and when they finish, they set the new start time for the schedule interval. So if I create this exactly at 12 noon, and it runs 1 hour later and it takes 15 seconds to run, it's going to set the start time to 1 o'clock and 15 seconds. So now when I ask for an offset of, if I were to say 1 hour, it's actually going to not be at the top of the hour. So we always make our offsets based on the moment the policy runs minus the offset of interval time. And so it's honestly, it's just a little bit tricky. I've seen people do various things. If I were to put 1 hour here, there's a chance I wouldn't get data for the most recent hour that just passed, depending on kind of when the thing runs. And that might not be what I was expecting. So that's why it's a good question. It's not tied to the rate of the data coming in. So in your case, like NFT, let's say it was second data. I would not put an end offset here of 1 second because it's not really going to do much. Here's what those two values are doing. They're defining this blue window that Timescale is going to look for new or modified data. And so if it runs 1 second after the hour and I say the end offset of 1 minute, I guess I could lose out on, a little bit of the previous hour. Yeah, you know what? That's a great question. I hadn't put it. I was just doing this with Miranda last week. It's like drawing not the Venn diagram, but it's like a timeline of saying, well, if it runs here and I minus this, and then you draw it again, but if it runs here and I minus this, I think that maybe the takeaway for me is you're about to see the policies don't update the current bucket. And that's one of the big misunderstandings. And so when this thing actually runs, if I am currently right now for me, I'm in the 12-hour time bucket Eastern. It doesn't matter what I set this to, right? If I set it to 1 minute, I'm still ending in the 12-hour bucket. It's not going to change anything for me, right? I'm not going to get any data materialized for that bucket. Now, if I were to set it to 1 hour, now I would be getting data from 12 hours ago until, again, if you can stick with me here, I'm in Eastern time zone right now. So the end offset, if I said 1 hour, would actually be 11:30. So we're only going to look in that window, which means that I'm only going to get data updated 12 hours ago up to 11 a.m. And the reason is we only update full buckets of time. So I just like to keep it at this point, trying to keep it within the bucket of time when the thing is probably going to run in most circumstances.
And the one thing which might be tricky for beginners. So now we are talking about refresh policies, but even if you the last or you mentioned the scenario where the most recent bucket doesn't get updated, so it's not materialized. But when you query the continuous aggregate, you will still get the data. The difference is that it won't come from the materialized table; it will come from the actual hyper table using real-time aggregates. So that part, might be. I don't know. Technically, it's probably not the right term, but that part might be coming, in a less performant way. But everything else is coming from the materials view, which has been already refreshed.
Yeah, you're absolutely right. So that's one thing we're going to talk about, mostly because both you and I, even with the NFTs, I feel like I don't create new materialized views enough, and I forget. I remember I think you even reached out and said, I keep creating this thing with no data, but why am I seeing data? So we're going to talk about real-time views in just a minute when we get to SQL. So last, querying aggregates supports full SQL over top of it. So you can join the output to tables. It does get, the query planner benefits of hypertables, right? So we can exclude partitions if your data isn't within that time range and so forth. And again, hopefully it saves computation time because we're storing some part of that data. So here are the common questions I came up with. I had these written out somewhere else. I thought, well, I'll just put them here. So I apologize if they're not the clearest questions. It's hard to materialize these as English sometimes. So I'm just going to run through these, and then we're going to go to a demo and hopefully hit most of these. If you end up watching this at a later date or you're watching now, if there's a different question, please don't hesitate to comment. And the next time we talk about continuous aggregates, we'll try and get to that. So number one is I specified with no data, but my continuous aggregates still return data. Why? We're going to show you, and it's exactly what Attila just said. So now I'm just realizing on screen. So back in my childhood, we used to watch the Brady Bunch, right? So they would have like the blocks. I don't know if you knew who the Brady Bunch is. You probably do, right?
Mm,
You ever heard the Brady Bunch?
no idea. No.
Okay. Well, I actually have a Brady Bunch because we have a bunch of kids. But anyway,
Is it like a
but
cartoon or something?
no, it's a family that was like 2 adopted families. There was 6 total kids, 3
Oh,
from the husband, 3
yeah.
from the wife. They got remarried anyway. But so at the end, they would have their song, and I realized like I now need to look down because you're below me, and they would do that. Like, on the screen, they would pretend to look at each other in the little boxes on the screen.
Right.
Anyway, I keep looking this way, but I should be looking down to talk to you. Anyway, so we both have run into this. We both see this often. I have an hourly time bucket, but I want to delete raw data every 10 minutes to save disk space. So someone wants a really cheap instance somewhere. And so every 10 or 15 minutes, they're importing real-time stock data, and it's 100 megs or 500 megs of data. And they just want to delete it as quickly as possible so they don't have to pay for disk space. And they think that, continuous aggregate is just going to magically work. And it just doesn't work that way. And we'll show you why in a minute. And the reality is, again, we're always aggregating a full bucket of time. So if you have an hour bucket, we are going to query the whole hour. And if you have now removed part of that data, your values are just going to keep changing. It won't actually be, we aren't aggregating it in 10-minute slices. We're always aggregating the full bucket. So we'll talk about that. So the answer is no, you can't do that currently. There are some other options. Why can't I create a continuous aggregate over another continuous aggregate? Attila, how many times have we heard this?
Well, I guess a lot of times, I guess,
Countless, huh?
when you have something, you know, so good, you just want more of that, and you want, and
I
you wanna,
know, right? That's it.
yeah.
Yeah, it makes sense. There are some architectural decisions that were made a couple years ago. I will say that a lot of it initially was around the knowledge that multi-node was coming and trying to make them performant for multi-node. But it has, done some other things, and we keep working on that. My continuous aggregate is getting slower as time goes forward. Why? Well, again, we're going to talk about policies, and it's almost always a misunderstanding of the most current bucket and what is and isn't aggregated, particularly around real-time aggregates. And finally, continuous aggregates use more storage than the original data in some cases. That's 100% true, and I'll show you why that is. And it comes down to those partials that we're storing. Remember, you might be summing, an integer, expecting that what gets stored is an integer. What's actually stored is a couple of things: the total count. A sum's not a good example, but average, right? The total count, the total number, and the function needed to come up with that data when you ask for it. That's the biggest reason that it comes up now. So let's try and attack some of these with the demo. So we've about 20 minutes. It's probably about time to go through this. See if I can get it to come forward. So this is the NFT data. So for those of you who don't know, I think I have this somewhere. We came up with a tutorial. There's a blog post coming as well. But we have this tutorial about NFT data. So this is what I've run through. You can Attila worked on this with someone else here. It comes with superset dashboards, a Grafana dashboard, scripts to load the data, which I'm using, a schema pre-built for you so you can start to explore this data. So it's really easy to get going. You literally check out a repo, set up a database, which you can do for free at Timescale Cloud, and then you just set your connection and start getting data. We even provide a backup of a few days worth of data for you to get going. So that's what I'm using. And this is the schema that's in that example. So I've done all this work and I've started to ingest data. I have about, there you go. I have almost 500,000 rows of data. We're kind of limiting the data we're getting from OpenSea. It's maybe a day. It's about a week's worth of data, I believe. Well, let's see. My min and max time. So October 29th until today. So a little bit more than a week's worth of data. is what we're about to work on. All right. I'm going to drop, I don't know where I'm at. I've been playing with this enough. So I'm going to drop this if it exists. And I'm basically recreating, and I'll just show you quickly over here in this demo. This is the portion about schema design. And then here we talk about analyzing. And in the analyzing section, one of the first things we talk about is materialized views, continuous aggregates. So I just took one of them. I took the collections continuous aggregate. In this example, it's a 1-day continuous aggregate. Okay, so I wanted, because I only have a few days of data, I wanted to show you a couple features. So I've simply taken this and just made it hourly. So you'll see that I've done essentially the same thing. I may have gotten rid of 1 or 2 values in here for simplicity. It is otherwise the same thing. I've just changed my time bucket to 1 hour. All right, so it's an hourly time bucket. Now you'll notice that I'm running this as we go. Let me just show you that. How do I want to approach this actually? It's a really good question. Because I flipped over time, let's let it be. So I'm not saying with no data. I'm just creating this on the fly. When I don't say with no data, it took 2 seconds, but it actually creates the materialized data as of right now, right? So it ran that query. If there was a year's worth of data, it would probably take some time. It might take 2 or 3 minutes, but it would actually create the materialized view in the continuous aggregate for you. So, and then I'm going to go ahead and set up a refresh policy. And this is similar to what I had. So let's say, even though this is an hourly bucket and I'm getting data every few seconds, every time this runs, every hour, in case something old comes in or I update a value somewhere, I want this to look at the last day of data. The end offset is just going to be the last minute. So it's pretty up to date. It's almost real time-ish. And you'll see what that means. And then I'm going to have it run every hour. And so I'm just going to set that policy up. And I got that policy. I'm going to do the exact same thing, but this time I'm going to say with no data. And the reason I'm doing that is we give this as an example in documentation. If you have a lot of data, let's say you have years worth of data, you have a couple billion rows of data, and you run that continuous aggregate, it will start creating that at that time, and it's going to wait until it's done. And so what we often recommend if you're creating something new on a lot of old data is we'll say with no data. That creates the view, gets things set up, but nothing gets stored until you either manually refresh it. So maybe go back in time and just refresh chunks. It could take minutes if it's a lot of data. Or you set up a refresh policy, and what it's going to do is fill in whatever the range is for the window, and then you have to go at some point in history and update the historical time. So a lot of people do this. You'll see that it's, what did I do here? Oh, I didn't drop it. Let me do that real quick. Drop materialized view. This. Okay, so I've been playing with this earlier. Here we go. All right, so I'm going to create that, and you'll see that it's instant. It didn't even flash for the 3 seconds it needed to create the data. So I have 500,000 lines of data for the last 10 or 11 days. Currently, the time in UTC is 1746. That's the current time in UTC. So I'm going to first query from the continuous aggregate that had data up until just right before the top of the hour. And so I'm going to go ahead and do that. And you'll see
it's
that
materialized already.
And it's materialized, yes. So I queried this data. I think it's materialized. So let's go ahead and see. And the way we can do that is we can turn off real-time aggregate. So let me go ahead and do this. Because I flipped to the top of the hour, let me show you something. This would be a better example. I'm going to go back and I'm going to remove this. And I'm going to call this little script forward that we have. I'm just going to run the script, and basically it's going to find data that's in the last few minutes because I've updated it right before we started. So you'll see that it got data for 1738. So again, UTC, we're in the 5 o'clock hour. So this is recent data. It's going to take a few seconds to get this. And we'll let that go. And then as soon as it gets past the hour, I'll go ahead and redo that so that we can see this. And this is one of the areas that gets kind of confusing. So I'm probably about done. We'll see here in a minute. I think it's going to try and keep getting the data and just not change anything. So I'm going to go back here. So let me go ahead and recreate that now. So now we know, let's just verify. I have data, at time UTC. So it is 12:47, so it's 17 UTC. I didn't change that up here. So now I'm going to go ahead and create that data. All right, I got the view. I have one with no data. I haven't done anything, so that doesn't change, right? Because it started with no data. The time is 17 UTC. Now, if I query this at UTC, you'll see that I get data for the 1700 hour. All right, so the question is, was the data for the 1700 hour materialized or not? And the way that we check that is we can turn off real-time aggregates. So what we've been talking about this whole time is by default in Timescale 2.0, actually in Timescale 1.7, I think, when you create a continuous aggregate, by default, it is created as a real-time aggregate. And so we did the hard work for you. We query what has been materialized, and then we query any period of time after the end of the materialized data, and we append it together for you and give you the value back. In a lot of situations, that's what people wanted. Maybe, I get data every so often and I don't always keep things refreshed. So they just want to make sure that they always get what appears to be, honestly, kind of the same view you would expect if you just run the raw query on the hypertable. Right? You'd expect the same values. The
Yeah,
problem is that, go for it.
yeah, I just agree. Like that's the, that's what your intuition tells you. Like this is what it should return. So it's really cool
Yeah, I
that
mean,
we have this feature.
people assume it, right? It's like if I have a continuous aggregate and I'm importing data every minute and I refresh that data every minute or two, I just expect that querying the raw hypertable or the continuous aggregate is just going to give me the same view. When it didn't, that was confusing to people. Well, wait a second. I have the data there. Why isn't it materialized yet? So we do that. So I'm going to turn off real-time materialization. And now I'm going to run the same query. Now, this is interesting because I decided to import new data. So I think what you're going to see here is that we actually still have 1700. And we do. And this is actually the first point of confusion for me sometimes, even doing this a lot, is you get a little bit different result depending on how the data is first set up. Because we didn't say with no data, what actually happened is it literally ran that query at that moment as a hypertable query. And so when you create a hypertable, we don't put the guardrails on it. We just run the query, and wherever you get, we actually materialize. And so we end up with a bucket of time in the current hour. That's what you would actually see. Now, from this point forward, when we do something like a refresh policy, now I can't, well, we're going to wait till the top of the hour. There's not a lot more to do, but we'll actually do something. We'll go right over the hour to show you. But when the policies run, every other way that you update data, we don't update the current bucket of time. So I'm in the middle of the 12 o'clock hour. I can refresh till the cows come home, as we say here in the country, but nothing is going to be saved to disk until the hour has passed. And it honestly kind of makes sense. If you want us to materialize the whole bucket of time, why would we materialize 30 minutes of the hour, right? That value is not the correct value until we get to the full hour. The problem is people create their aggregate and the very first thing they see is this, and it looks like it's correct. So we're just doing it a little bit differently. That has been a source of confusion. Anyway, let's go ahead and go on. So I'm going to create this hourly bucket. I'm going to create this hourly bucket. It's going to basically run at the top of the hour. We'll make sure it does a little bit later just in case. And we got this. So that's now going to run in the background. That basically is going to run every, this case, is going to run every hour, but we'll make sure it runs in a little bit. Doing that didn't change anything. If I were to import data now for the last 2 or 3 minutes, the values wouldn't change. So now let's go look at the continuous aggregate with no data, right? So same exact thing, except we just said, now in this case, don't actually materialize the data yet. So we're going to go ahead and query it. And this is where a lot of people start to get confused. Wait a second, where's this data coming from? This looks just like the data I queried from above. And why is it doing that? And this is where it's really begins to be clear. I'm going to do this. Oops. I'm just going to do an explain analyze here. What this is going to show us is what Postgres and TimescaleDB is doing under the covers to get us this data. And real-time aggregates actually does that append for us. You'll see a select query here and a select query here. So one is the real-time portion, of which there are 0 rows. And then we're appending to it everything after the last time of the refresh. But there's been no refresh. There's been no data. And so the appending went and queried the raw hypertable and got me my aggregate data back. So that's the first thing to recognize, that even when you do that, this is where I think some confusion comes in, is people will say, oh, I created that data with that continuous aggregate with no data, and now I'm querying it and it's just working. This looks great. It turns out they've never materialized any data. They're just always querying the hypertable. And therefore, after a few days or weeks, what's probably going to happen?
It's going to be slow.
It's going to be slower.
Yeah.
We're bypassing the materialization.
Yeah, usually that's the point where they come to Slack and, hey, why is this slow? Like, it should be fast.
Right. So what we should have done here, and I'll do that in just a minute to show you, what we should have done is set up a refresh policy. And so I'll do that in a second. So here's, to prove to you that there is actually no data in there, I'm now turning off real-time aggregates. Only return materialized data from this continuous aggregate. And you see now I get nothing. So nothing's actually been materialized, but I didn't know that because it looked like it was working. So it's like, it's that blessing for a lot of people. I don't have to think about it. I'm getting the most recent bucket of time as if I were running the raw hypertable query, but it can be confusing if you don't set it up. So now let's talk about that timing of refresh policies. So I'm going to leave real-time materialized data on, but I'm going to create this refresh policy for no data. All right. So I'm going to refresh. You know what? And just to do this quickly, I'm going to go ahead and take. I'm going to go ahead and make this. Since there is no data in here, I'm going to make this 3 days up to 1 minute. So as soon as so this is the next point. When you create any policy in TimescaleDB, and I think this is true, if I'm wrong, I'll try and correct it next time we talk about this. Every time you create a policy, whether it's a refresh policy, a data retention policy, what are other policies? My brain is not picking out here.
Compression policy.
Compression policy, thank you. When I run this query, it sets it up as a policy to run on an automated basis, but it also runs it once right now. And so when I do this, it should refresh that hypertable if the demo gods are with me today. So that's that. I'm going to set this up. So it should have run it in the background. And remember, I said the end window, we have data into the 15-hour, right? I'm sorry, the 1700-hour UTC. So I said, get me all the data up to the most recent minute and create those buckets. I should have data like I do for the other one, I would assume. So now I'm going to query my no data one. So now it's been refreshed. And you'll see that I only have data up to the 1600 hour. Yay, the demo worked. And the reason is, again, when that policy runs, we only update, regardless of how much you run it. If it's an hour bucket, we will not actually save a value to the database. until you were past the hour. Now, if you had 3 hours of data that were missing and you filled them in, let's say from, now I got to do my math, from 1500, 1600, and 1700. So I hadn't run the script in a couple hours, and I import the last 3 hours of data. When the policy runs, because I am out of the 1500 and 1600 hour of time, it will materialize that data. If I were beyond the 1700 hours, so in just 3 minutes, I'm going to run this manually again. And you'll see that we will now get a 1700 bucket. We are not checking to see if the bucket has data from beginning to end. We're simply saying, if you're in the middle of that time bucket, we're pretty sure you haven't gotten data from the future. And so we're going to wait until we are out of this current time. So what does that mean? If I have a 6-hour bucket or a 1-day bucket, and I think this is where the bigger confusion comes in, you can run that continuous aggregate refresh as much as you want today. And if it's a 1-day bucket, we are not saving data to the database until you are literally out of this day. So something to think about. Any thoughts?
Well, just one slightly unrelated about time buckets.
Yeah.
Like I saw some confusion, like what that time bucket value means, and that's the beginning of that time bucket.
Yeah, thank
Because
you for saying that.
some people think that it's the end of that period, but no, it's the beginning.
Yep, absolutely. Good call. Anytime you use time bucket, whether it's in continuous aggregate or just by yourself manually, running queries, it's always the beginning of the bucket of time. So good call. All right, so it is 12:59. I just want to show you a couple other things to try and answer a few of those questions. And as I said, we will talk about continuous aggregates again and again and again, partially because we're adding more and more features. I think you're going to see a lot of really good stuff coming in the next few months. There's a lot of good internal conversation. We're solving some of the problems that we've been, that we know will solve your problems. It's all just a matter of learning and making sure we do it right. So you know what, it's about to flip over the hour, so it's now 1 p.m. So I could do this. I think. So, hey, here's a little tip. If you want to call or a refresh, so we can do a couple things. We can select timescale information, job stats. And so this is last successful finish. Oh. That's not what I expected. So let's go see what jobs we have. I'm just going to highlight this. I'm not confused on this one. I expected to see my refresh job in here, so I wonder if I have something set, and I could, and I might not be paying attention here. Well, so here's the deal. I'm not 100% sure why I'm not seeing that. Maybe because it hasn't officially run on its own once. Huh. Okay, so this is live streaming.
Didn't you drop the continuous aggregate?
Maybe.
And then or I don't know, and then they run the
Oh, you
manual
know what? Maybe I
refresh.
did. Thank you. That really could have been it. So let me see if it's there. Huh. All right, having something's going on here. I'm not 100% sure, so we're going to move on for the moment so I can tell you one or two other things. My guess is if I were to, so this is, again, that no data. You'll see that it did run in the background. So for some reason, the view's not showing. It could be maybe something I have in 𝗵𝗽𝗻 that's messing with me. You will see now that I'll just verify that that is off. So, okay, so because we left the hour, we went past all of 12 o'clock Eastern, 1700 UTC, the policy ran and it did refresh data. I now have a materialized bucket. even though I don't have data for the entire hour of time. But now I'm in the 1 o'clock or the 1800 bucket. I could start importing data as much as I want. It's not going to get materialized until I'm fully out of this 1 o'clock hour. All right. Not sure what's going on with the jobs views. That could honestly be me. I hadn't done that earlier. Maybe I just have something set up. So that's 2 or 3 of those first questions are really discussed in just those 2 examples. When you create a view with no data, it doesn't mean that you won't get data back. It means that you're only querying from the raw hypertable until you refresh it in some way, manually or not. The other thing I was going to show, so I'm in the, in fact, let me just do this really quickly. This should not take long. I'll go ahead and ingest some data for, let's see if we have some for the 1 o'clock hour. And, oh, not quite. Okay, so, well, maybe ended, I think, up until this time. So let's assume we have data for, the 3 or 4 minutes we are now in this time. If I were to, had something I wanted to show there. Oh, if I manually refresh. So let me do that. So I'm going to say, oh, that's what it is. This is, oh, I am so sorry. I didn't set up a job for this. I'm calling this manually. Man, my brain is not. This is manually refreshing the policy. I hadn't yet set up a policy for this one. I'm so sorry. That was my bad. So that's why we don't see it in the jobs table. So let me show you this. I'm now in the 1 o'clock hour. It doesn't matter if it was a policy or if I try and say, hey, I'm in the 1 o'clock hour. I have new data. Please refresh. And I tell it that, right? The start window is 3 days ago, up until the most recent minute. I expect data for the 1800 hour, and I'm not going to get it. So I just wanted to hit that point home one more time. So it doesn't matter if it's a policy or if you call the refresh continuous aggregate procedure, it will never materialize the current time bucket that you're in. Whether it's a minute, 10 minutes, an hour, a day, whatever that bucket of time is, you won't actually save it to disk until you're fully out of it.
And then if you want to only see data that is actually materialized, you need to set that, only materialized only equals true.
Yep.
And that will
yeah, so you're absolutely right. So
set
now if I say
real time
false,
off. Yep.
if I turn it off, so now it's saying, give me materialized and most recent data. And now I run that query. I expect to see an 1800 bucket, which I do, right? Now that's only 3 minutes of data, right? There's just 3 minutes of NFT data in this database because I just ran it. That's what you get. Great call. All right, so let me just show you. So that's the no data thing. That also attacks my queries getting slower. Recently had a user in Slack say, hey, I have a, actually, I think it was a 1 hour bucket, but they were getting 2.5, 3 million rows per hour with data that honestly, the query pretty much had to scan all of that data to get the answer, to get the result. And so as the hour went by, their query got slower and slower. And honestly, they didn't realize that real-time aggregates were turned on. And they also didn't have the data indexed as well as it probably could have been for the query. And so all the data up until last hour was really fast. When we turned off real-time aggregates, the query got fast. So as the most recent hour, as 100,000 and 500,000, a million rows of data came in, because it was literally scanning data, it just was slow. It wasn't actually the continuous aggregate that was slow. It was the data. So, so there's that. There's the no data thing. There's the what bucket of time is actually materialized and so forth. So I want to attack one of the last ones for today. And we've shown this a bunch recently. One way forward. So this doesn't solve one problem, which is I want to create aggregates on top of the current aggregate. So this is a piece of that. What it doesn't solve is if you already have a continuous aggregate. So a continuous aggregate is materialized data. If you've already materialized the data, columns and all, you cannot modify the query underneath of it, because that kind of makes everything null and void, right? And remember, what we're storing is the partials of information we need to reproduce the value for you. And so if you now change the definition of the column, anything historical changes. So this doesn't necessarily help you at the moment. if you want to take advantage of something like reaggregating data and you have a year's worth of history. We know that's something we would like to try and provide a resource for, something we've talked about a lot and I didn't want to talk about today. Hey, I have a continuous aggregate, but I really want to, change it now to be, instead of an hour, I want it to be a day, but I want to keep the data and I want to, well, if you've already deleted data or something of that nature, I can't get it back for you. We're talking about it. If you want to create a new continuous aggregate, we are now starting to provide these new functions called hyperfunctions. So you'll see I have a blog link here. I'm just going to show you that blog. Got a lot of good attention for good reason. The title of the blog is how Postgres aggregation works and how it influenced our hyperfunctions. And so this is essentially what's happening in Postgres. If you say the average of something, it's feeding every value through, tracking the count and the total, and giving you the value. With hyperfunctions, we can store the intermediate states of those, kind of like we wanted to do previously, and then we can reaggregate them. So here's what I'm going to do. I'm going to take that query, and before we were getting the mean value from this percentile ag, we actually stored, I'll show you that. Notice up here, we actually called the mean and the approximate percentile on those values. Well, we don't have to do that now. If we just store the percentile aggregation, I can get multiple values out of that later when I query the continuous aggregate. I can get the 50th percentile, the 90th percentile. I don't have to store that at the time of materialization. I store the percentile ag, and then I can get the values I want later. So that's a huge win. And then you'll see that we can actually reaggregate them. Same thing with hyperloglog. Any of these functions that can be rolled up, we've had a number of people ask about. So I'm going to create this. I'm going to drop it in case I have it. So it has the newest data. And I'm going to create this. And what I'm storing, what have I done? Oops, sorry. I was playing with something earlier. What I have done, there we go. Let's create that. All right, so now what I have stored is an aggregate price. Now, I could get into it maybe later in a different view. I'll show you how. But what's in the CAG data now? Well, now I can just say, show me that mean price. And it's an hour-long bucket. So I'm doing too many things here. I'm trying to. So I got 20 rows. I didn't order by, let me order by 2 descending. Right, so that will get me the. So now I can see I have data for 1300 hour. This is not a UTC, but that's the 1 o'clock hour for me in the 18 hour in UTC. So I just got a mean value, right? I could do something else. I could say, well, wait a second, those are hour-long buckets. Let me do, tell you what, I'll order it by 1. So I'm ordering it by collection ID descending. You'll see that I have hour buckets by default. I didn't say time bucket, I just said whatever you have in there. But now, this is something you couldn't do before. If you tried to do this before, you would get, for instance, the average of averages. So now I can say time bucket, roll up all of those buckets of the aggregate, the aggregation we have underneath, and get me the mean of that hour. So this is kind of what a lot of people have been wanting to do, right? So I'm gonna, I'll order it, same thing. All right, so I'm gonna forget about that limit 20. So same deal. So now I have, I think order by that. So I have each collection, and now you'll see that it's actually a day's worth of time. So that's really cool. That's one of the things that people have been wanting to do. And if you're willing or able to create a new aggregate and these functions work for you, we have a percentile aggregation. We have a counter aggregation. We have a bunch of them, and it's all held underneath. There's a couple of blog posts, and then you can look at how to use hyperfunctions in our documentation. So under how to and hyperfunctions, we have all of this stuff. It links to the API docs. And so for instance, you can do count distincts, which can be, that's hyperlog. And so that's what I'm doing here as an example. Again, I have 1 hour buckets that I materialized, but I'm now going to group them by a day. And I'm going to get the, in this case, the mean and the distinct count of, in this case, the hyperlog was on collection ID. So the distinct count of collection ID references within that bucket of time. And so this is way faster than doing a select distinct count on all of this data. Even at 10 days of data, if I were to do that, and I actually haven't done this in a while, so I don't know. Well, I'll tell you what, until I'm just going to do this. This would be, in theory, all of the time. Oh, but I didn't group. Sorry, I need to group by. I'm not getting the buckets. Sorry, this isn't the best example because I needed to group by the buckets. It would take longer, particularly on more data, and I'm not doing a good example there. And actually, count distinct on that, we're probably getting some benefit from Timescale there. So a lot to cover. We've gone over a little bit. Honestly, and I just say this, we could just keep talking. If you watch this, you have questions, please put them in the video so we know what we need to update in docs, how we can provide better examples. Something like the NFT example is a great tool for you to learn this, right? Because now you can actually have a script that's continually ingesting data. You can set up different aggregates. You can test some of these new hyperfunctions. You can see exactly how it's working, which is a huge benefit to you as a user. Thank you so much, 𝗔𝗲𝗏, for putting in the work to do it. We'll hopefully come up with more of these examples over the next couple months. But hopefully this is we've hit a bunch of those questions. I don't know if there's others that we should have answered, but it's a good start.
Yeah, I think it was great. If people want to get the ingestion script, there will be links in the description. Everything is on GitHub. You can just clone the repo, and you need to specify the database connection details and a time frame that you want to get NFT data from using the OpenSea API. So it's very simple, and you can fill up your database with I would say hundreds of thousands of records in a matter of, I don't know, like a couple of hours or something like that.
Yeah. I probably, whatever, I have 10 days of data, 11 days of data, and it took me a couple hours. That's running from my machine here, and latencies and all those things. It would just run. It's great.
Yeah, and then this data set will allow everybody to try continuous aggregates, try with no data option, and just play with it.
Totally agree. Yeah, and so I'll put a plug in for your stream tomorrow. So tomorrow on Wednesdays, 𝗔𝗏𝗏 and Jonatas are going to be streaming for the next number of weeks about crypto and stock data. Tomorrow, you're actually going to talk more about this NFT data set,
NFTs,
the schema we used, things like that, how we came up with currently the schema and ways maybe you would have changed it, some of those things.
Yeah, I'm going to be talking about the schema. Also, maybe I touch a little bit on the ingestion script, some of the data fields, and how we inserted NFT data into TimescaleDB, yeah, basically that's it.
Awesome. Yeah, it's going to be great. Really easy to follow. Everything you need's in here. I'd suggest anyone go follow this. There are a ton of queries in here. Great examples of some new ways to start to use Timescale. I mean, I could just keep scrolling and scrolling. There's dashboards. You did a great job. So, all right, 𝗔𝗏𝗏, thanks for your time. Thank you, everyone, for tuning in. And we'll do as much as we can with the links down below to continuous aggregates, other examples, other videos. We want you to learn this and be really successful with it. And we're doing our best to make them better every release. So thank you.
Thank you, Ryan. See everyone.
Have a good afternoon. All right. Bye-bye.
Bye-bye.